Welcome to week 2 of Introduction to Virtualization. This week, you should have already completed the following. You should have already read chapters 1, 2, and 3 in the book. You should have completed the proposal justification section of the virtualization project. And you should have submitted your receipt to me, and then I would return you with an access code to the hands-on labs. And get started to pick at those labs as well. The 5 weeks of this condensed course are jam-packed with information. So it's important for you to stay on pace in order to get everything done by the end. Okay, let's begin. Okay, so in the beginning here, we're going to be going over the project proposals you're doing first. Now, the intent of these project proposals are to give you a real world experience as to what it's like to create a highly technical, in-depth report for a job, right? So in this case, it's as if you were hired on to the IT staff at EM, and your first task was to give a proposal for bringing the CST department from a physical environment to a virtual environment. And so it'd be perceived that something like the computers that are in the classroom would be exchanged into or changed into thin clients, and there would be server architecture running the environment in that classroom that could be tapped into either in there or outside, and have presumably desktop environments, or however you feel that it should be set up in order to best handle the education that happens in the curriculum. Now, I want you to make sure that you're handling the details of this report in a really professional and in-depth manner. This isn't something where, again, you need to talk about in necessarily the I sense. You should be saying the CST department should be doing this because the X, Y, and Z, and I can justify X, Y, and Z with this report or this research. This, when doing this sort of report, it's not necessarily important to include citations, except for when you're really kind of going out on a limb, or maybe when money's involved and you're saying the Eastern Maine Community College should be spending $20,000 on this machine, and this is why, right? So then you would validate it with some sort of link. So with that in mind, on the first section, when you just previously worked on, the project proposal, it's a good idea to take a second pass at what you submitted and really dig deeper into what you put in there the first time. So not only should you be talking about how the proposal overall is good for Eastern Maine and what's virtualization from a textbook example, but talk about why things would be going and why there should be time, effort, and money spent on this change. How could it improve the experience for students? How could it improve this experience for faculty? How could it expand the reach of the current systems that we have in place? What specifically is going to be impacted from a physical network side, from a virtual network side, from a physical computer side, from a virtual computer side? Give specifics, right? How can this improve faculty experience? How can this improve student grades, possibly? Really dig into the details of this sort of thing. Don't treat this as this is virtualization, copy paste from some website, and then be done with it. Really dig into it and make this make this as real as you can by putting yourself in the shoes of somebody that really wants to get this accomplished. If what I've just talked about helps you understand how you can do things better, along with the notes that I gave you in my EMCC, I highly encourage you to revise that first section and possibly give yourself a better grade. What you'd need to do, however, is resubmit and make sure to put a note in my EMCC that you revised that section, um, or even when you submit this week's, just revise section 1 as well. And still put a note in my EMCC that you revised this section so that I can go back and give you a better grade. Um, and that's going to be something that you can do consistently throughout the whole 5 weeks, so the remaining 4 weeks, is revise. I'd love for you to revise and dig deeper and do everything a little bit better the second time around, right? It's never perfect the first time. And when you do that, again, just put a note in my MCC so that I can go back and give you a better grade. I'm not going to know what you changed from week to week. You need to bring that to my attention. The next part of the project proposal that you'll be working on this week is the inventory process. Now, in the inventory process, um, you should not necessarily worry about doing a technical review of the current needs of the computer science department or computer systems technology department uh, here at Eastern Maine. Um, you should you could certainly generalize it. You could generalize it saying there's 20 computers per room that generally need to do X, Y, and Z on a given day, and those general requirements are this. You could even jump on, if you wanted to, you could jump on a computer and see how much RAM is on there, see the processor, they're all the same. And just to get a kind of a technical feel for what's going on in the room. Um, and also have an idea of what the network requirements are, um, what the what what the students have to do, what you have to do on a given basis, on a daily basis in order to log in and use the computers. If you're not a bring your own device student, if you're logging into a computer, what actually happens when you put in your username and password and hit login? Where does that information go? Where does it come from? Could that information be housed in the computer systems technology department exclusively? Does it need to go? Does it need to phone home? Can there be some sort of intermediary server set up that could be done with this sort of thing? Um, but really start to get a feel from a technical perspective, from an IT person's perspective, what's happening in the room, right? And then think about where things are going to be going in the next year or two. In the next year or two, would you expect that student population would increase? Do you expect more students to come into the CST department? Do you expect less students to come into the CST department? Um, do you expect programs to expand, stay the same? Um, if there's more students, what does that require? If there's more programs, what does that require? You take that 1 to 2 and expand that again into 3 to 5. In 3 to 5 years, um, how much more usage of the computers is going to be needed? What resources are going to need to be available in order to facilitate the need that you are projecting over the next 3 to 5 years? Because in the next 3 to 5 years, you are going to want to purchase the equipment or plan for the need that you're perceiving in this process you're doing right now, right? In this report that you're doing, from a business aspect, you want to plan ahead, right? We don't want to buy for today. We want to buy for 5 years from now. So what does that mean? What does that look like? And then you want to look into the proposal into, again, more technical detail. We want to take a look at server resources. What is actually being impacted when you access your email, when you log in, when you go to print? What is happening on the network side from an Eastern Maine Community College IT perspective that we could possibly virtualize and take ownership of in the CST department. Are there any terminal servers currently being used? Could they be used? Could there be dedicated web servers? In the book, it talks about application servers. Could there be a server architecture set up in CST that looks like that, but feels like something just in-house? And then what you would need to do is figure out these server resources that are currently being used. How can I facilitate those? How can I project to make those happen in the future and currently based on what's needed, based on the need that I just talked about in the report, right? So an example of that would be a file server. In a file server, hopefully there are redundancies put into place for disaster recovery, and hopefully there are network resources attached to a file server that facilitate server resources being, or file resources being accessed quickly, right? If you're posting a full virtual machine or something onto a file server, you want to be able to up and download that stuff quick. Are there legacy applications that are part of the curriculum right now? Are there old pieces of software that are currently being used, taught, anything that would need to be put onto those servers in order to continue the status quo as of today? How could that change in the future? And then what you want, so with all this detail, you can kind of break it up from level to level to level. You can look at it at a very high level. You don't talk about specifics necessarily. You're not talking like a 10/100,000 speed NIC that needs to be put into every thin client. What you'd be talking about is high bandwidth. And this is all in the process of showing not only that you understand kind of comprehensively what's needed for a network, what's needed for a computer to access a network, but also what it would mean from a virtualization perspective to flip it from physical to virtual. Because there is a switch there that needs to be considered in order to make sure that it can work correctly. And this is all showing technical understanding. So there should be jargon in here. You should be able to, flex some technical muscle and show that you really do understand this information. In this report, I want to see numbers. I want to see charts. And that's what your boss, or that's what a decision maker would want to see if you were to do this for a job professional. All right, now on to the book. In the book here, you should have already read chapters 1, 2, and 3. And every week, I'm going to just be going over things that I feel are important from my perspective, and it's good for you to know from a practical perspective. With that being said, the pre-test, the weekly quizzes, and the final are all focused on the book, so it's your responsibility to read through those chapters. It's a really easy read, and understand what the content is supplied in those chapters. Now, if you don't understand something or you want to dig deeper, I highly encourage you to just come to class ready with those questions, ready to talk about those. Shoot me an email, do whatever you'd like, and I'm happy to indulge on any part of the content of the book that I don't necessarily cover in a lecture during class. All right, so understanding virtualization. In order to understand where things are today and where things are going as far as servers are concerned and virtualization, it's a good idea to have an understanding of how it started, right? And that can give you perspective on where things are going. To help with that, let's watch a little commercial.
Our network is out of control.
It's all these servers. I need more people.
I think we should buy more servers.
But that's the problem. Too many servers.
The servers are our friends. They want to serve us.
He's lost it.
What do we do?
Switching over to IBM servers. Easier to manage. We can control everything from here now.
Stop! You're making them angry! No!
Take back control with the IBM eServer X series featuring reliable Intel Xeon processors.
That little commercial just gives a brief insight into what the rapid server growth of the late 80s, early 90s into mid 90s was like from a virtualization perspective and from a server perspective, where you could really see the effect of Moore's law, right? Where technology doubles every 18 months. And what that would do is that would make it so there's all these really newly powerful servers being implemented all over the place. And businesses were relying more and more on computing and file storage and network bandwidth. And it was with all this new expansive capability, this new horsepower, it was servers and virtualization that really took ownership of what businesses were needing from a computing perspective and allowed business growth to expand as fast as Moore's law. The book talks about lost servers. Lost servers are also addressed in that commercial, where server growth was at times so expansive, servers that people would log into, that nobody really knew what they were doing or why they were set up initially. You might have to dig around, and it was more of a risk to shut them down than to keep them going, than the cost benefit to keep them going. And the book talks about what percent of a given organization's servers are virtualized. It's 70%, and that's old data. It's even higher now. So to know that if you are looking to get a job at a given business, you can assume that there's at least some virtualization happening there. And maybe they're not at the 70%, but for you to come into the job knowing virtualization really comprehensively from a business perspective and from a practical perspective, this is going to be a great benefit to you during the hiring process for somebody that might not have done this otherwise, right? Especially from an entry-level employee perspective. So those are just good numbers and good perspective for you to keep in mind going forward in this class, and for you to know when going out and looking for jobs after you graduate. In the next chapter, it starts to dig into hypervisors and kind of a throwback from the past. Why are they called hypervisors? It's just good to know that they're called hypervisors because they give the overseeing look into code, right? The code was designed to be kind of the top level. Then the hypervisor needs to be on top of that. So that's why it's called a hypervisor. And what it actually does is really important for you to understand from an IT perspective, not just to know that you install some piece of software and allows you to put a bunch of Windows 10 machines on top of a Linux box or whatever, but to know that the hypervisor is the intermediary layer between an operating system and hardware, and how that actually functions, and how how the hypervisor acts as a translator between the operating system and the hardware that it's sitting on, and how it does resource allocation is, again, really important for you to know from a business perspective and from an IT person's perspective, not just kind of a general knowledge use. So again, look into that chapter and look into maybe some of VMware or Microsoft's technical documentation to dive into it deeper. With that being said, the difference between a type 1 and a type 2, this is something that if you have taken the server class at EM that you would have gotten already. But the difference between those two is type 1 sits right on top of the the bare metal, and type 2 is like VirtualBox, where it can sit on top of an existing host operating system and then install and be used otherwise. Install virtual machines within that host operating system. Cost efficiency, again, is something to look at from a business perspective. There's arguments with licensing on either side of whether or not you want the licensing for a bare one that sits on the bare metal, like a Microsoft or a VMware or Citrix. It sits on the bare metal of type 1, paying for the licensing for that, and then having one kind of beefy server that sits on, and then worrying about Windows licenses or different operating system licenses on top of that, versus what sort of license and chipset you could facilitate with a type 2. And then you could also put in their performance cost, where the performance of a type 1 hypervisor is potentially faster than a type 2. With all of these slides, with all these things, I try to extend the knowledge a bit. And so what I'd like you to think about, and I won't answer for you in here, but how can hypervisors be used with Internet of Things? Right. So if you don't know, Internet of Things is where everything's smart. Fridge, toaster, chairs, I don't know, whatever, TVs. And how can hypervisors be used with that? How can a virtual machine play into that world? In the previous slide, we talked about you being a more attractive potential employee for a given business. Businesses are using Internet of Things all the time. Consumers are using the Internet of Things constantly to meld the worlds of virtual machines and Internet of Things. Think about how that could be used together and start to expand kind of the use case of both of those worlds. So something to think about. All right, next we're going to talk about what's different about physical machines versus virtual machines as far as resource allocation goes. Now, this is something that you should have addressed if you took the server class already. However, it's just good to know that you account for resources in a virtual machine a little bit differently than you do a physical machine. Where in a virtual machine, you can expand resources, you can balloon resources. Ballooning RAM, ballooning memory is something for you to look into. But you can kind of expand and contract as needed, where in a physical machine, it's not really that easy to throw in another stick of RAM, throw in some more hard drives, add more cores to the processor as it is from a virtual machine, just kind of doing that from a GUI interface. So it's good to keep that perspective when not only setting up the project, but also just establishing a virtual machine on a computer. And an extension of that, it's good to understand how data is actually retrieved by an operating system from a disk, knowing that RAM is the pass-through from an operating system. The operating system goes through the CPU, through the RAM, to the hard drive, and then kind of back through in order to access information. That path, that resource allocation is an important thing for you to understand when setting up a virtual machine, right? So if you understand that that's the path, then what's the bottleneck? What's something that you need to be aware of when serving up full operating systems to hundreds of people? How do you make that happen? What resources need to be established on both the hypervisor side and the physical machine side to make sure that there's no bottleneck for your users? Or the other thing to think about as far as getting more granular into storage are the protection rings, ring 0, 1, 2, and 3 on a hard drive, on a disk, and how they're used from a virtual machine perspective. Knowing that the smaller the number, the more protected it is, and the bigger the number, the less protected. That's 3 is where applications live. 0 is where the hypervisor is, but 1 is where the kernel is when a virtual machine is established on a computer. Um, Knowing that the user is out on 3, the virtual machine's on 0, but it's good to know that there's ingrained checks and balances put in place and how the hypervisor actually operates on a very basic hardware level. All right, now the last slide I'll talk about as far as the content goes is um, the different ways that you can have redundancy when it comes to virtual machines. That's kind of the power of a virtual machine, is that you can create copies in multiple ways, and we'll talk about the ways, to make it so if a virtual machine dies, if the software dies and the hardware lives on, it's kind of like a copy and paste, but not really, um, to allow your the facility to continue to run, to make it so business can still happen really pretty quickly and easily, um, based on that software, just moving software around. So a template is a way that you can set up a virtual machine, um, with all the software configuration and kind of virtual machine configuration settings necessary to be copied over into multiple others. Think of a template as just like a template that you would get in Word or something else, where the structure is already there. You're just filling in details. Um, a clone and a snapshot are very similar, where a clone is typically the entire virtual machine as it was running, as it was going, but it's powered off, and you kind of copy that and throw that somewhere else for storage as far as a clone goes. And a snapshot is as a virtual machine is running. You take a snapshot of the virtual machine, and you can store that somewhere else and then restore it as you need to in order to go back to where you were before. Which again, this is something that doesn't exist too easily in the kind of the regular computing world, um, but exists in virtual machines, and that's in the virtual machine world, and that's the power of a virtual machine. OVF is the the kind of open source file format for virtual machines. Can be moved from different manufacturers, different developing companies, VMware to Microsoft to Citrix to IBM, um, using the OVF format. That's good to know. That's how that's done. And a virtual appliance is a way to go kind of extend past a template, kind of like a template and a clone together. So you set up a operating system, set up a virtual machine to do a specific thing, kind of like you would a template, but you fill in those details. And so it can then just be installed and ran and go to do the specific thing with minor configuration done after the fact. A virtual appliance is designed to have you up and running, doing whatever you need to, doing a web server, doing application server, whatever you need to do for that virtual machine. So that's kind of the power of the virtual machine and allowing disaster recovery and redundancy to happen with little to no downtime. All right. Well, I'm done talking and done going over the curriculum. So now it's time for you to pause the video, stop the video and come back to it, whatever you want to do. But take this week's test. It's in my EMCC. It covers chapters 1, 2, and 3 from the book. And again, these quizzes are meant to show me that you understand what's going on, and will kind of give me the ability to switch gears if I need to next week, and showing me what you know. Once you're done with the test, I would like you to work on labs. The labs need to be worked on every week. There isn't a lot of labs there. Some of them are kind of hard. They're all covering VMware. VMware is the most widely used virtualization software in the world, so it's a good thing to get in to know how to do. There are only a few labs that are assigned to you, but you can do them all when you have access to the labs for a year. It's a really, really good resource for you as far as that goes. So remember, today we covered what to do in the 5-week project. We covered chapters 1, 2, and 3, and then a little more. We covered what you should be doing in the hands-on labs and how to do those. So if you're making a to-do list, the next thing for you to do is the inventory process in the 5-week project, the virtualization project for CST. Read chapters 4, 5, and 6, and of course the labs. And I will see you next week.